Hi, welcome to this tutorial on GeoPandas, the Python library GeoPandas, where you would be able to do various types of manipulations and analysis of spatial data in Python interface itself. So GeoPandas is basically an open source project to make working with geospatial data in Python much more easier, and it also actually extends to data types used by the famous data analysis library of Python called Pandas to allow spatial operations on various geometric types. So let's get started. So in this tutorial, I'm going to show you how to import shapefiles into your Python interface using GeoPandas, and how to visualize those shapefiles in Python, and how to perform some simple manipulations, and finally how to save your manipulated file as an ESRI shapefile, so that you can actually use other GIS tools such as QGIS or ArcGIS to open those files again. So first of all, I would like to give you a quick outlook on the code editor which I'm using, which is called as Spyder. If you would like to know how to install Spyder, I have also created a separate tutorial. I will put the link down in the description below. Along with that, I have also prepared another tutorial to show you how to install GeoPandas library, because installing GeoPandas might not be that straightforward, so I have created a separate tutorial for that as well. You might want to check that tutorial out before you start with this tutorial. And talking about the code editor which I'm using, which is Spyder, you can see over here this would be the area where I'd be typing my code in. And over here you can see that we are working with three tabs, which is the variable explorer, the file explorer, and help. So under the variable explorer, if you were to assign anything to a variable, that will actually show over here. And file explorer, you can sort of browse through to the folder which you would like to work on, and you will actually be able to visualize what are the files inside that folder. So in my case, I'll be working in this particular file, which is C GeoPandas tutorials Belgium, and help is sort of obviously self-explanatory. So I would like you to actually create your own folder where you'd be working on. So as I told you, I would be working in this particular folder. You can actually go over here and browse to the folder that you would like to work on. And I'm going to create a new Python module. So I'm just going to right click over here and go to new module, and I'm going to name this as Intro to GeoPandas. Alright, now you can see that we have a new file over here, and inside my folder you can see that we have few files. So I'm just going to go ahead and import the GeoPandas library as GPD. And the very first thing that I'm going to do is I'm going to import a shapefile. So as you can see over here inside the folder that I'm in right now, you can see there are two shapefiles, area of interest and Belgian cities. So first of all, I'm going to import this shapefile called Belgian cities into my Python interface, and I'm going to assign that shapefile into a variable named cities. So I'm going to create a variable called cities, which is going to be equal to gpd.readFile. And as you might guess now, this read file is an inbuilt functionality which comes with GeoPandas, which lets us quite easily import shapefiles to our interface. And over here we're supposed to give the file path. Just going to go ahead and copy and paste it over here. And my shapefile is named as Belgian _cities.shp. So whenever you need to run your code, you can simply click over here on run file, or you can just simply hit F5. So I'm just going to hit F5, and in your IPython console you see that you did not get any error, which probably means that your code was working fine. And if you also go to your variable explorer now, you can see that we assign some data to a new variable called cities. So I'm just going to go ahead to my IPython console. I'm just going to visualize this cities variable. So just for me to get myself familiarized with what sort of data which I'm working with, I'm just going to go and find out what is the type of this variable of cities. And as you can see, it's a GeoPandas geodataframe type. Now if I want to visualize only the first 5 rows of that of the cities variable, I'm just going to type cities.head. Okay, now you can see that we have 2 columns. The first column is called name, and the name underscore 4, and the second column is called geometry. So this name column contains names of different cities, and this geometry column is actually a unique column which comes with GeoPandas data frames. Also you can type cities.columns to see what sort of columns you have, and again you can see that we have 2 columns, name 4 and geometry. So what I would like to do now is actually how I would like to visualize this shapefile in Python itself. So I'm just going to import another library called matplotlib. matplotlib.pyplot as plt, and I'm going to visualize this file by simply using this command cities.plot. That's it, and I'm going to run the code again. Alright, now you can see the map of Belgium, and you can see that inside this map we have sort of so many splits, which are actually the boundaries of each city. Now if I want to know how many cities that I have, I can simply type cities, which actually gives the length of the rows, and we have 589 rows, probably which is attributed to 589 cities. So I also want to actually introduce few coloring options for this map. If you go over here and inside the brackets, if you specify CMap color map, which stands for color map, and you would be actually able to assign a few types of colors to this map. Now I'm just going to use this type called jet, and if I run the command again, you can see that sort of randomly assign some colors to my shapefile. If I type cities.head over here, you can see that I have one column called name, where all my cities are listed under. So I'm just going to pass another argument called column, and I'm asking it to color my shapefile based on the elements of my column, which means based on each of the cities. I'm just going to give the name of my column, which is name 4 in this case. Right, I'm going to run the command again. Okay, now you can see that the colors were assigned again sort of randomly, but based on the names of the cities now. Now if you would like to increase the size of this figure, that's also possible. You can add another argument inside this brackets called fig size. I'm going to assign a size of 10 by 10, and I'm going to run the code again. Right, now you can see actually it's a much better representation of our shapefile. So I'm just going to go ahead and comment out this part, importing and plotting the cities shapefile. So the next step would be actually to import another shapefile, which is called as area of interest. So I'm going to actually specify an area of interest, which is also defined in terms of a shapefile. So similar to this step over here, I'm going to just copy and paste this part, and I'm going to change the variable's name to be AOI, which stands for area of interest. And over here I'm just going to change the name of the shapefile to be this shapefile, area of interest. Alright, now I can go ahead and run that command by simply pressing F5. Seems to be alright. I'm also going to visualize the AOI shapefile which we just imported. Alright, now you can see that this area of interest is actually a circle. Now, as you might guess right now, this area of interest shapefile should actually be placed on top of this Belgium shapefile, Belgian city shapefile, so that we can actually see visually what sort of areas of interest have been specified by this shapefile. So what I'm going to do is I'm just going to comment out this one, importing AOI, importing and plotting AOI shapefile. So my next task would actually be to plot these two shapefiles together. That means one shapefile on top of the other. So that's what we're going to do now. Display both shapefiles together. You first define two variables, fig, ax, which is going to be equal to plt dot subplots, and I'm going to assign 1. And then I'm going to take my cities shapefile and plot it, and I'm going to assign ax to be equal to ax, and next we have the other shapefile, which is area of interest, and I'm going to plot that one as well. Right, now I can just go ahead and run this command and see what happens. Okay, now you can see, even though you cannot see very clearly since the figure size is quite small, you can see that our area of interest got placed on top of this Belgian cities shapefile. So I'm just going to go ahead and make a few changes for us to better visualize this map. So I'm just going to go ahead and add a few more arguments to cities.plot, where I'm going to specify a different color map, and this time I'm going to assign a color scheme called rainbow. Now you might wonder where I get these different names like jet, rainbow for this color map option. You can actually go to this Matplotlib guide, and under choosing color maps you can actually scroll down and see different types of color schemes and what kind of names that we can assign to those color maps. So the one that I assigned, which is called jet, you can find it over here, you see, and this is the rainbow. But if you would like to use different color schemes, actually you can use it from here. So I will also put the link down in the description below for this information, for this page with information on different color schemes of Matplotlib. So I'm going to assign the color scheme, which is CMap, to be rainbow, and also I'm going to assign the colors based on my column, which contains the names of the cities. Alright, now we can go ahead and run this command. Okay, now you can see that actually in the background we have the cities map, and over here we have the area of interest. Now instead of using this C map, you also have the option to use another argument called face color, where you can actually directly assign a color. For example, for the area of interest over here, I'm going to pass this argument called face color. I'm just going to specify that face color to be, let's say, yellow. Right. Okay, now you can see that the color of this area of interest actually got changed to yellow. So this is how you actually display two shapefiles together using subplots. And my next task would be, I'm just going to do a very simple basic spatial operation, which is intersecting these two layers together. So I'm going to use the overlay function of GeoPandas in order to do that, and I'm going to assign the intersected intersected information to a new variable called cities in area of interest or something like that. Now, so you can simply go ahead and assign a new variable, cities in area of interest. That's going to be equal to gpd.overlay. That's the spatial operation that we are going to perform now, and I'm going to overlay my cities shapefile with AOI shapefile, and we pass an argument called how, and we have to specify how to be intersection, because we are going to intersect the two layers. And I'm also going to plot this layer as well, cities in AOI dot plot. Probably I'm going to increase the figure size to be 1010. Right, I'm going to go ahead and run this command. Now you can see actually we got all the cities which belongs to that circle, which is our area of interest. And if I were to assign a different color scheme, let's say cmap equals jet, and I'm going to run this one, and now you can see that we assign different colors based on the different cities. I would also actually like to see how the attributes table of this new file looks like. So I'm just going to copy this cities in AOI from here, and I'm going to paste it in my console. Looks a bit complex, and now and as you can see, now we have the cities which are actually located within that area of interest. Now if you would like to actually visualize the attributes table in a much more user-friendly way, you can also go to Variables Explorer, and now you can see that we have got a new variable which we just created by doing the intersection, which is known as cities in area of interest. You can just simply double click over here, and you can also actually visualize the attributes table in this manner. 217 different cities which are actually located within that our specified area of interest. Alright, as our next step, I would like to actually do a very simple operation now, where I'm actually going to create a new column using Python, and I'm going to assign the area of each cities to that new column. So let's go ahead and see how we can do that. Now GeoPandas has an inbuilt function called .area, where actually it will calculate you all the areas, the areas of the polygons to you. So for example, if I type cities in AOI area, it'll actually show you the areas of different cities. But I would like to assign this information to a new column. Now this area is actually calculated in terms of square meters. Now how do I know that? It actually depends on the coordinate system that you are using. So for example, if I take my cities shapefile and if I type .crs, it will show you the information of the coordinate system that you're currently using. So since I'm currently working with data of Belgium, I know beforehand that this data have been assigned. So these data have been assigned to a coordinate system which is called Lambert 1972, which is a projected coordinate system. And over here you can see the units, which is m dot area. You should know that these values correspond to square meters. So I'm just going to actually assign a new column. And you can very easily do that by assigning the name of your new column, which I'm going to call as area, which is going to be in kilometers squared. I'm going to divide the whole thing by 10 to the power 6 so that I can get the areas in terms of kilometers. So let's go ahead and run this command. Alright, now I'm just going to check my cities in AOI file again. And from here you can see that before it was 3 columns, and then now we have added a new column which is area in square kilometers. And if you would go to the variable explorer now, double click on this one, you can very easily see that we can see the different areas of different cities in terms of square kilometers. So that's pretty cool. And finally, I'm just going to wrap up this tutorial by showing you how to save this newly created GeoPandas geodataframe into a shapefile. So that's going to be quite easy as well. So how do you do that? You can simply type cities in AOI dot to file, and then you can assign the name. I'm just going to use the same folder, so I would just go ahead and copy this and paste it over here, but I'm going to change the name. Let's call it as intersected cities. Alright, now you can just go ahead and run the command. And if you check in the file explorer over here, we created a new shapefile called intersected cities. So that's pretty cool. Now you can use different GIS tools like QGIS or ArcGIS to import this newly created shapefile, which is your intersected cities, which also contains a new area, new column which we defined using GeoPandas, which specifies the area of each of the cities within our area of interests. So I hope you enjoyed this tutorial. And if you have any questions, do comment them down below, and I hope you would subscribe to my channel because you would be able to see many cool GIS tutorials in the upcoming days. Thank you.